Okay, so let's go ahead and talk about some right triangle trig. That means we need to remind ourselves of some special right triangles. So we have, of course, some of our favorite triangles here, which are our 45, 45, 90 triangle, meaning that you have your 90 degrees of 45s. As a reminder on these, of course, it's an isosceles triangle, so those two are congruent, and then your hypotenuse is your side times the square root of 2. And then your other triangle, other special right triangle, is going to be your 30, 60, 90. So your 60 degrees and your 30 degrees, and you have your short leg here. Your hypotenuse is double your short leg, and then your long leg is your short leg times the square root of 3. And if you need to go back and kind of look at those, you're welcome to look at where those come from. But number one, you need to memorize these, right? It's really important that you have these relationships down. So this is your 45, 45, 90, and this is your 30, 60, 90 triangles. So important on those. All right, other things that we talk about in terms of triangle are, of course, your trig functions. So you're going to go ahead, of course, we have sine, and that little symbol there, right there, that's theta, right? So this is talking about theta. What this is going to go ahead and refer to is an angle in a triangle. Let's actually go ahead and sketch that triangle. So let's see about a right triangle here. There we go. So there's our triangle. Here's our right angle. And then you have angle theta. Let's just call it this angle down here. When we're talking about these, our relationships, of course, are going to be your hypotenuse, which is opposite your right angle. You have your opposite side and your adjacent side. So your hypotenuse, opposite side, and adjacent. And that, of course, depends on the relationship of theta. If theta is over here, this is now your opposite side. So it depends on those. Okay, so talking about our sine of theta, that is going to be your opposite side over your hypotenuse. Other trig functions that we have here are cosine theta. If you guys remind yourself here, this is not sin, this is sine, right? This is cosine, which is going to be your adjacent over hypotenuse. And then, of course, tangent theta is equal to your opposite over adjacent. And it's the relationship between, like, the angle side is equal to that relationship there. And then, of course, you also have the reciprocals. So our sine, the reciprocal of sine theta, or 1 over sine theta, is equal to our cosecant theta, which is equal to now the opposite of it. So it's going to be now hypotenuse over opposite. Sorry, the reciprocal. I shouldn't say opposite, the reciprocal. And then the reciprocal of cosine, or 1 over cosine theta, is equal to secant theta. This is now hypotenuse over adjacent. And then your very last one is going to be your 1 over your tangent theta is equal to cotangent theta, which is now adjacent over opposite, okay? So once again, we're talking about stuff. If you need to go back, memorize. If you need to go back and kind of look at where these come from, find a video on it, that's totally fine. But you need to know these relationships, right? You need to know that the sine of theta is the opposite over hypotenuse, and so on and so on. Okay, and the reason that, of course, you need to know that is when we jump into these trig or inverse trig or solving, this is what we mean by that. So for our example one here, this is going to be a right triangle. This is going to be our hypotenuse that we're solving for. This has an angle measure of 22 degrees, and this has a side length of 15. So given the fact that this has an angle measure of 22, this has a side length of 15, we're solving for our hypotenuse. It's not a special triangle, so we can't use those special relationships. We need to then use trig. So we need to say, hey, sine of 22 degrees is equal to opposite, so the opposite side is 15, over your hypotenuse, which is then x. All right, solving for x here, we know that x is equal to 15 over sine of 22 degrees. You can now use your calculator to go ahead and solve for x, and we're going to get that x is about 40.042. Approximately there, is always rounding to 3 decimal places. And if you didn't get that in your calculator, I'm going to go ahead and make a little bit of a calculator note right here, is that check to make sure calculator is set for degrees, because we're in degrees right now. I'm going to tell you right now, it's not always going to be this. We're going to actually go ahead and kind of change it around later on. But for right now, because we're dealing with degrees, it needs to be in degrees here. All right, and so this, of course, is our trig, but we also have the option of our inverse trig. And you may or may not have used these calculators on, these keys on the calculator. But now when we're using trig, we're using it to solve for the missing side length. When we're using our inverse trig, we're using it to solve for the missing angle. So on this one, we're going to have a missing side angle of theta, and we're going to know that our opposite side is 15, but now our hypotenuse is going to be 40. So we're going to say, same thing that we did before, is we're going to set it up as sine theta is equal to our opposite over hypotenuse. But now we're going to go ahead and use that inverse. So we're going to go say the inverse of 15, the sine inverse of 15 over 40 is equal to our angle measure. So we get that theta is approximately equal to 22.024 degrees. All right, so making sure that you know the difference between those, right? That you're using those trig and those inverse trig. And again, on this one, you got to double check that calculator, making sure that you're hitting those calculator keys correctly on this one. You got to go second sign, look for that inverse trig right there. A few key notes here is making sure that you know about your notation and your vocabulary. When you're working with a triangle, especially our right triangles here, we like to take our vertices and label them with, usually, I'm going to say usually, label them with capital letters, and then the side lengths are usually named with by the opposite side. So if this is a vertice C, this side opposite is going to be lowercase c. So it's going to be lowercase c, this is going to be lowercase a, and this is going to be lowercase b. And if we go ahead and take an angle here, let's just call this angle A for theta, meaning that this angle down here is going to be 90 degrees minus theta amount. All right, so just a little bit of heads up on your triangles. And whenever you see the instructions of solve for a triangle, right? So if you're looking at that solve amount for a triangle, it means find all measurements. So you might have a little bit of calculations there, and some of those calculations are going to be from things that you know about triangles. So let's talk about things that you might know about a triangle. Something that you might know is that the three angles, right? The three angles, their sum is 180 degrees, right? So on a triangle, you know that it's 180 degrees. The two angles on a 90-degree triangle, of course, add to 90 on that one. You also should know your Pythagorean theorem. I hope I spelled that right. Sometimes I don't. I also just realized I didn't capitalize it. Is going to be a squared plus b squared equals c squared. So using those in terms of your right triangles. Always good to know your trig functions. Like I said before, you got to be able to memorize those and have those relationships down. What's kind of cool is like, hey, on these isosceles triangles, so let's call this our isosceles triangle over here, is that you can always go ahead and drop a altitude on this. I didn't do a good job of lining up the altitude. So you can drop your altitude on here, which creates a 90-degree triangle. And then, even though this is not a 90-degree triangle to go ahead and start off with, now you've created two 90-degree triangles, and now you can use your trig functions. You couldn't use your trig functions before, but now you can to go ahead and find your missing side lengths on this. So also talking about altitude. Of isosceles. And then when you have a polygon, the apothem of a regular polygon so if this is a regular polygon, meaning all these side lengths are congruent. As a reminder on this actually, the apothem of this can be dropped down and once again creates that 90-degree triangle on there. So FYI, things that you might see or might need to use is that you can create a lot of 90-degree triangles if need be. Let's talk about the two things that will come up in terms of vocab. So you're going to have angle of elevation versus angle of depression. And this is basically the idea of, hey, if you got like a little, I'm going to kind of change colors here. So if you got a little person down here at the ground, right? And let's say they're going ahead and they're looking at this bird. I'm not an artist, so this is going to be my bird up here. So they're looking at this bird. So they're looking, of course, they're looking up at this bird, meaning that if we're talking about the angle of it, right, we're going to go ahead, we're going to drop down and create this right triangle here. So we have this right triangle. And we're talking about, specifically, we're talking about this angle, right? This angle right here. This is going to be the angle of elevation. And this is, right, person looking at bird. Now, the other angle that we talk about in terms of this is, once again, we have this guy down here on the ground, and we have a bird up in the sky, but now the bird is looking down at the guy. And so now when we create this right triangle here, right, now we're talking about the bird's point of view here, and this angle is going to be our angle of depression. So talking about those two different angles there, and it just all kind of depends on how the problem is written, so you want to be very careful with it, right? So this is bird looking at person. So that's going to come in handy when we're thinking about word problems and the angles at which things are being described in terms of that. The last part about triangles here, of course, is something about like a similar triangle. And this all depends on how you're setting it up. A lot of times you're going to see things like, hey, we have a building here, right? We have a building that we're working with, and we also have a person down here, and so on. So we know that the person is 6 feet tall, and we have some sunshine that's coming in. Let's change this to, right? So we have some sunshine that's coming in here and making everything wonderful and pretty, but it's also going to go ahead and cast a shadow. So we have the shadow that goes ahead and comes up. And what the shadow is going to do is that it's going to create two similar triangles. Hope I didn't get a chance to get this all the way to the ground. There we go. There we go. So it's going to go ahead and it's going to create these two similar triangles. This is not very good scale, but that's all right. Let's say that the person's shadow is 5 feet long, and we know that from the person to the building is 100 feet. So we're looking for the height of the building. So in order to figure this out, we of course are going to use our similar triangle properties and our proportions. So we're going to talk about this triangle right here. And we're going to set that up and say, well, if we have a side length of 6/5 is equal to the full triangle, right? So the full triangle here all the way up to the building. We're going to set up, as a reminder, you have to take the entire side. So we're going to say is equal to the 105 over your height, and then from there you can go ahead and solve for height. So just some triangle basics there, things that you're going to be using over the rest of the semester.